Hi and welcome back to PI Tech Talk, and to this second video in the beginner series where we're going to take a look on inputs. And the inputs will be a wider topic, so we will take it into two sessions, and this is the first one where we will look into polling inputs. And in the second video we will take a look into the interrupts of the inputs. So I hope you have the tools ready and tag along. Right, so here we are now in Visual Studio Code, and we start immediately with creating a new project, and I will take it quite fast this time. If you want to take it slower, take a look in the previous video so we don't make this video too long. So we go under create the STM32CubeMX program, and in STM32CubeMX we access the board selector. We type in what board we do have. And I will be running the C031 board. And as last time, just take a small look in the schematics first of all. So we open the schematics here. Here we have the schematics, and we can also now take a look in the two ports that we are interested in this video. And that is the PC13, that is the input. And the input in this one is the blue button that you possibly have on your Nucleo board as well. And this is working like this. It has a 3.3 volt pull-up resistor to this pin. So it's always 3.3 volt unless you hit this switch where all the potential will go down to ground immediately and you have 0 volts. So active on the switch is 0, it's a low voltage. And there is also an RC filter here, and with it's a capacitor and a resistor, and that is taking care of contact bounces that we will take a look in also. So for sure we now know that in steady state it's a high level, and we're taking a look when it's low, when it's under steady state low. And we will also be taking use of this LED that we did in the last video, the PA5. So PA5 is the LED and the PC13 is the input switch. We close this one and we start the project. As in the last video, we unselect everything and we hit OK. And as we did last time also, we just hit pin out and then we see clear pinouts. And this, I just take it as a repetition, so we will learn, but I take it much faster this time. So under clock configuration, we say no thank you, we will solve it on our own. And we will use the 48 megahertz internal clock, and we click it there and the clock tree is done. We need to then have the trace and the debug interface, so we double click on the debug and we enable the serial interface where we have the pins down there. Then we need to have an output, so we left click on the PA5, which was the output, and we put that as an GPIO output. We right click on it, enter user label, and we write LED on that one. PC13 was the input, so we left click on that one and put that as an GPIO input. And then we right click on it and enter the user label and we write BTN as a button. Great, so now we have a button input, that is the PC13, and we have a LED on PA5 and we have the debug interface. We go to Project Manager, we give it a name. So I've called it input poll, and of course, as we last learned, we need to put it as a CMake project. So we make CMake project and we generate code. So the project is done, we can just hit close and we can close the project. Back in Visual Studio Code, we now need to open the program that was just created for us in CubeMX. So there I have my workspace, and there is my project that I just created in input poll. So I double click on that one and I open. I hit debug, and I say that I would like to have it as a CMake project, so yes. Next thing we can do like that, we hit the setup the STM32 cube projects. And we see that it's a Nucleo board and it's a GCC, and we can just save and close that one. Next step, we can just try to build a project to see that there is no error from the very beginning. So if there is an error, we have created it on our own. It's at least not the CubeMX who done it. Now we need to then create a JSON launch file. So we hit that button, and then we create the launch JSON file, and we hit on the STM32 cube ST-Link GDB server. So we click on that one. That script is made for us automatically. We need to just save it. We can try to build it once more just to be fun. And now we have connected our board, which we can see here. So I have it connected and the LED is red, so it's waiting for communication there. So we start debugging. And everything is working with the program as well. So every code came down to the microcontroller. If we just run the code now, nothing will happen. If we hit the blue button, nothing will happen. So we need to create that program for us now. Next step. So we break that one again. All right, now to see something actually doing some work with the button, input button, I have now made some code here. And if we go under HAL init and we go down a bit further, we can see here in the while one loop that I put some code here. And now also important to make notice that I actually made an error in my last video. I put my code in this section here after the end and before the begin. And you don't allow to do that, because if you then recompile your project with STM32 CubeMX, everything in those areas will be deleted. So you need to be in between the begin and the end. So here in this case, we have a user code begin while, and then we have a user code end while. So that part is okay to put your code in. It will work if you do the other way, but if you then recompile or add something with STM32 CubeMX, then your everything with your code will be gone. So I put my code here, and then I have an if-else statement that I have put here. So we do like this, that we use the HAL library and we use the GPIO read pin. So we read the pin, and you remember that we named the PC13 BTN button. So if we just hover over this one, the BTN, we will see that it defines itself as port C. So it needs to know the port and it needs to know the pin, and then we have the pin, also the button pin, and the button pin is GPIO pin number 13. So we don't need to then remember it any longer. It's easy when you have one port and one pin, but if you have several, then it becomes more complicated to remember it. We're reading this GPIO PC13, and if that is in the reset state, and what is reset state? That is the value 0. So this GPIO pin reset, that is a variable, and it's equals to 0. And we remember when we looked in the schematics, when we pressed the button, then the input PC13 is low. So we're looking for if the PC13 is low. So if it is that means that we have pressed the button. So then this is coming into play the next line. And then we are doing like this. We drive the LED, we write the pin, GPIO write pin. So we write to the piece PA5. So we see a LED GPIO port, and that is the GPIO A. And the pin is number 5, so PA5. And we write what state. We can write high, we can write low, 1 or 0, but we also have a HAL statement called GPIO pin set, and pin set is equals to 1. So that means if the button is pressed, then we turn on the LED. And if that statement is not true, but it's false, then we have an else statement. So if this is still high, that means that no one has pressed it. Then this will just jump over this line and it will come to this line of code instead. And we do the same here. We then use the LED, but we put it on GPIO pin reset. That means that we put it to 0. So in this short sentence, we can say that if we don't press the button, the LED will be turned off, and if we press the button, then the LED will be turned on. So we run the code. It's a very simple program, but it's with a simple that you learn. So we program the code to the microcontroller, and we can see the microcontroller down here. And you see that there is a green LED, that is the power LED, and there is an LED next to it, and that is the PA5. So we run the code, and now we can't see much of it on the board because we don't press the PC13 yet, but if I do, then I expect that LED to be turned on. And so it is. Success. And if I let go of it, it immediately turns off. So that is a polling. We are like evaluating the state of a pin, if it's high or if it's low. And this is one way to do it. Another one is to do it with an interrupt, and that is what we're going to take a look into the coming video. So hope that you have learned something from this video. Give me some comments below if you learned something or if you have some thoughts about it. And stay tuned for the next video. Stay safe. Bye.